All right, let's get into it then. Um, we're going to start out with this line graph. You'll notice this picture that we're looking at here shows change over time. So we have time on our x-axis. Change over time, we're going to use a line graph for that, and that's what we've got here. And what we've got are teacher salaries. So as I look at this graph, what I see here is, okay, well, in 1990, the teachers in this district made $30,000 a year. In 2000, they made $32,000 a year, and then in 2010, their salaries rose up to $38,000 a year. And your first glance at this picture, your first thought might be, oh my gosh, that's not very much money. Well, we don't know where this district is. Maybe it's a rural community in a smaller state. And this is 1990, 2000, 2010. So, it's a while ago. But as far as those numbers go, it looks awfully flat. It kind of, just looking at this picture, it's like, boy, they really didn't get much of an increase over that 10-year period. And they got a better increase here, but not much. It looks like their salaries have been relatively flat. If you were in the teachers union, you would point to this picture and say, look at this. Over the last 20 years, our salaries have hardly changed at all. We are definitely in need of a raise. And that's what you see here in this picture. If you're somebody in the public looking at this picture, like, wow, they haven't gotten a raise at all, hardly. Now what I want to do is look at this graph. And at a quick glance, you're like, these are teacher salaries also? Because what I'm seeing here is they had a pretty good increase there, and then holy cow, a huge increase over here. Where is this district? That's the one I want to work at. Well, hold on a minute. Let's take a look at the actual numbers and see what we see here. In 1990, they were making $30,000. In 2000, they were making $32,000. And in 2010, they were making $38,000. Hey, wait a minute. 30,000, 32,000, 38,000. Back here, 30,000, 32,000, 38,000. It's the exact same data, just presented in a different way. Anybody see what changed between this graph and this one? And if you're reading the pages there, you can kind of see a little bit of a hint, but still, if you want to put it in your own words, that'd be great. Yeah, that's right, Jennifer. If we look, and yes, it's kind of right there on the slide, but if you look at the numbers on the y-axis here, we start at 0 and go all the way up to 38,000. The way that I'm going to describe this is that we have zoomed out. This is as far back from the data as we could pull back. We pulled way the heck back so that we started at 0 and went up to 38,000. When we do that, this is what our change looks like. Our change over time looks pretty small because we've zoomed out. Then in this graph, when we look at the y-axis, we're going from 30,000 to 38,000. This range here that's on the y-axis is only 8,000. Instead of going from 0 to 38,000, we have zoomed in. We're zooming right in on where the data is. Going back to this picture, what we've done here is we have taken just this part of the y-axis and zoomed in on it. That's what we've done in the second picture here. Another word for when you zoom in like that, an important word for our class, is truncated. And what that means is we cut some off. It used to go from 38,000 all the way down to 0. What we did here is we truncated, we cut it off and only did from 30 to 38,000. So we truncated this part of the axis, we cut it off, and we're not showing that. Now, if you're the school district and you want to say, our teachers don't need a raise, they've gotten significant raises over the last little bit of time. I mean, take a look at this picture. They had a nice increase here, and then we gave them a huge increase in those years. The data is exactly the same. It's just depending on who is showing you their version of the data, it might give you a different perception. And that's an important thing for you to know, mostly as a consumer, but also as somebody who might teach graphs sometime down the road, that when we zoom out like this and show the entire y-axis, the change that we see looks less dramatic. Sure, there's a change here, but it doesn't look like much. When we zoom out like this, the change looks less dramatic. If we want the change to look more dramatic, if we're the school district and we're like, hey, we're going to put together this graph, if we want the change to look more dramatic, then we're going to zoom in. We're going to truncate the axis so that the change looks more dramatic. Let me know if you have any questions on anything there. But that is definitely a technique that is used when data is presented to give you one side or the other. Depending on which side you're on, you're going to produce a graph that gives your side the strongest case. Okay. This can also be done with bar graphs, not necessarily just with line graphs. If we look at trucks that were sold in the last 10 years that are still on the road, if we look over here at the graph on the left, it looks like, holy cow, Chevy is way better than Ford, which is better than Toyota, which is better than Nissan. Look at that drop off. It's tremendous. I'm going to buy the Chevy. Hold on a second. A little closer inspection here shows me that this only goes from 95 to 100. Heck, more than 95% of the Nissans are still on the road. That's awfully good. What we've done here, or what the graph maker did here, was they zoomed in. They truncated the y-axis, and that makes this change, or the difference in this case, not so much the change, but it makes the difference between Chevy, Ford, Toyota, and Nissan look more dramatic. If instead we were to zoom out and show the entire y-axis all the way down to 0, and now when we look at that picture, it's like, well, heck, they're pretty much all the same. And that's because they're all between, roughly 95 and 98%. So there's not going to be a whole lot of difference if we look at the picture zoomed out and we see the entire y-axis. So this is something that can be done with line graphs. It's also something that can be done with bar graphs. Here's a misleading graph. State and local property taxes. And what you see in this picture is, it's a line graph, and it is change over time, but I'm going to let you all tell me some things that you might do differently if you were the one making this graph. But it looks like, wow, what a sharp increase. It's leveled off. It leveled off. It's still going up, though, and it's not as bad in recent times. Tell me some things that you notice about this graph that sort of take away from the validity of it. Make it not so, I'm not sure this graph is so good. And it doesn't, I'm not necessarily after, specific language. Just tell me what you see here that doesn't seem right to you. And if there's nothing, I guess that's possible, but seems unlikely. There's a couple of things that really jump out. All right, both of those are great. Jennifer, I agree. When you normally put time on the x-axis, we tend to read things left to right. As we read this graph, it looks like it kind of levels off here, but wait a minute, this isn't time down here. So reading this left to right doesn't really make sense because that's not how it's framed. The time is here on the y-axis, which is just weird. It wouldn't make sense for us to kind of turn our heads and read this. If we turn our heads way to the left and we see 1940, 42, 44, and Now it kind of looks like things are going down, but that doesn't make any sense because we can see that the billions of dollars number is going up. So yeah, I agree, Jennifer. It's kind of very unusual to put time on the y-axis. As soon as I see that, I think something's not right here. And then Denise, you're exactly right. They started merging years together. We've got individual years here, and then all of a sudden we do 64, 65, 69, 70, 71, 72. Well, what is that? Why did you decide to change from just a single individual year to merging them together? So, but those two things alone make me think something's not right here. They're trying to hide something from me as a reader of this graph that's the way I would hope you would read it. There's another thing that's a little more subtle, but if you look really closely at the years they've chosen, okay, this is a 2-year gap. All right, that's fine. So it should just be 2 years all the way. 2 years, 2 years. Hey, wait a minute. Now you jumped 4, and you jumped 4 again, and now you jumped 6, and now you went back to 2, and then you did this weird thing where you joined years together. There's all kinds of things wrong with this y-axis over here. So whatever they're trying to show in this graph is there's probably something happening in there that they're trying to prevent you from seeing. I don't know that that's 100% true, but it sure feels like it when you look at a graph with that many things in it that are unusual. And as we go through these, you can let me know if you have any questions at all. Another thing we can do besides manipulating the axis is changing the size of the image that we use. Now, typically when we make a bar graph, we just make a bar and we make a bar over here. But immediately at a quick glance at this, you see, okay, this is textbook prices 2010 and 2020. And holy cow, they're a lot higher in 2020. While that may be true, the creator of this graph has done something where the bar was this wide for 2010. And if they had made the bar that same width for 2020, we would say, yeah, it's definitely gone up. But what they've done here is kind of fool you with the area that's involved. There's, holy cow, look how much bigger that one is. Textbook prices have really gone crazy. Just by making this one wider, it gives a much bigger impression than is actually there. And essentially, we're just looking at some examples of ways that a graph can be used to manipulate data to give you a perception that may or may not be true, or it may be on one side of the issue and not on the other. Cherry picking data. So this is stock price for Amazon over certain periods of time. If we look at the graph down here on the bottom right, we can see that over this 4+ year window that included 2014, 15, 16, 17, 18, we can see that there's sort of been a general gradual increase for Amazon. If you've invested in Amazon over that time, you've done pretty well. However, if we wanted to cherry pick just a certain piece of this data and say, you know what, instead of showing the last 4 years, we are just going to show the last month. And in the last month, what happened is if you invested, yeah, you gained a little at first, but it started something, oh no, it went down. You lost money. So if you wanted to make the claim that investing in Amazon is not a good idea, you might say, well, look at this graph right here. You can clearly see the trend that the stock is going down. Well, what's happened there is the person presenting this data has cherry picked this one little dip right here and zoomed in on it so that let's just talk about the last month, not what's happened as a trend over the long term. And this is something you could do to give a certain impression. In a school setting, an administrator might use standardized test score from their 11th graders who happen to be really strong and say, look how well we're doing, instead of using 9, 10, 11, and 12. Or they might use their third graders because they know that happens to be a really strong cohort of students and say, look how well we've done, versus showing data across the board. I'm not saying that ever happens. I'm just saying it could, that cherry picking data is something that could happen if you want to give a misleading impression of what the data actually looks like. There's also not necessarily a right or a wrong way. I mean, maybe the only year of this specific thing was tested was third grade, and so it makes sense to report the third graders. But the idea that you could cherry pick to give an impression of good or bad is something that can happen. The next thing we'll talk about are a couple of definitions. And those definitions are for reliability and validity. And this is basically about your data set. So now this isn't so much about how you present the data as much about how you collect the data. Is it reliable? Is it valid? Reliability refers to the consistency of the data. Would you get the same results if you did this data collection or experiment again? You know, if you took a survey and then you went and did the survey again, would you get similar results? They don't have to be exactly the same, but would they be similar? And the construction of the survey would have something to do with this. Where the survey is taken would have something to do with this. And the key for you to know is that when we're talking about reliability, we're talking about the consistency of this data set. Could we do the same thing again and expect similar results? Validity is about how accurate the data is. Does it really measure what we're trying to measure here? So validity is about the accuracy of the data, meaning if I want to know how many people are Raiders fans, what percent of the population is Raiders fans? Well, if I take that survey in Las Vegas, I'm not sure that's going to be that accurate. I need to take a nationwide survey if I want to know the percentage of Americans that are Raiders fans. Taking that survey in Las Vegas is going to mess up my accuracy. Taking the survey nationwide would be more accurate. The key here is unbiased, random samples can be used to make valid conclusions. If we want our conclusions to be valid, then we need an unbiased, random sample. If instead we take a biased sample, then we're not getting the data that's representative of what we're looking for. So those two words, reliability and validity, are very important in our study of data and statistics. And it's important to understand that they don't mean the same thing. Reliability, could I do it over and over again? Validity, does this really measure what it's supposed to? That's what those two words are about. All right, I have a question for you. A new landfill is going to be built near a town. A survey is conducted by interviewing the 100 residents that live closest to the proposed location of the landfill. And it's found that 90% of them are opposed to the new landfill. Does this mean that 90% of the town is opposed to the landfill? I'm going to set up a poll for this. Now, there's no calculation for you to do here. All right, so a survey is conducted by interviewing the 100 residents that live closest to the location of the landfill. 90% of those people are opposed to this new landfill. Does this mean that 90% of the town is opposed to the landfill? We'll go another 20 seconds on this and then we'll talk through it. Let's see what we've got. Okay, not unanimous, but pretty close. We've got strong agreement here. We're going to make sure we make a case for this one. So the idea here, what we're running into a problem with is a problem with the validity of this. And the problem that this survey has is the 100 residents we surveyed live close to the location of the landfill. So, almost certainly they're going to be against it. But other people in town might be like, well, yeah, we need a landfill. It's got to go somewhere. And so if we were to do something different, we might get different results. That's a reliability issue. Also, the validity of this comes into question because, well, we did a very specific surveying that might not give results representative of the whole town. My question to you is, what might we do to survey people about the new landfill? Instead of the 100 people closest to the landfill, what do you want to do instead? And there's a lot of ways you could answer this and be correct. I'm just curious to see what you come up with. There's no pressure on this one. Survey the whole town. Okay, might be more costly than surveying 100 people that live closest to where the landfill will be built, but that's not bad, Shelby. 100 random people throughout the whole town. That's fantastic, Jennifer. They're going to live who knows where. We have to kind of figure out how we're doing random. Used to be we could use a phone book and do random. We can't do that anymore. But I'm sure there's a register maybe of people who pay property tax, or you could, Shelby's way, you could put a ballot in everybody's mailbox where they could vote yes or no. You could have um, there are different ways you could go about it. Jennifer's got the key there is, instead of just the 100 people closest to the landfill, if we want a true representation of the town, we need to find 100 random people. However we do that, put everybody's name in a bowl and draw out the first 100 and ask them. There are a lot of ways we can do random, but random is the key if we want to have a valid collection of results. Another question for you. If we wanted to know the favorite restaurant of CSN students, would a survey of students at the Henderson campus give us valid results? I'll do a poll for this one too. We'll go another 15 seconds and then talk about this one. Let's see what we think on this one. Again, strong agreement, not unanimous. This one, I don't know that this one is entirely as clear cut as the other one. I lean towards no on this, like many of you. And my rationale there is, well, what if we get, restaurants that are sort of native to Henderson that don't really exist over by West Charleston or up near North Las Vegas? And so, we're getting results that the people at West Charleston or North Las Vegas couldn't possibly give those answers. So that sort of invalidates. If we're trying to say what is the favorite restaurant of all CSN students, we've limited ourselves to just one localized campus. You could argue, well, people from all parts of town all go to the Henderson campus to take classes, so they know what restaurants are down there. Or, well, there's pretty much the same restaurants all over the valley. You could make that case, I guess. But here I would lean towards, no, that's not going to work. That's not going to be valid. Instead, we would want to survey students at all three campuses, and heck, maybe even online students that that don't really travel to one of those campuses on a regular basis. And that's how we would get valid results for the favorite restaurant of CSN students on the whole. If we wanted to know what's the favorite restaurant of CSN students who attend the Henderson campus, then absolutely doing a survey of students at that campus would make sense. So a little bit of it is, what is it that we're trying to find out? And if we're trying to find that out, then we want to make sure the survey we're doing gives us that kind of information. The big idea here with reliability and validity, just think about the questions you have and how the data is collected. That's going to be, did we really survey in a way that's going to give us an answer to the question we were asking? And then as far as misleading goes, this how it was presented is more about the misleading angle. Did they zoom in or zoom out on the axis to cause a situation that looked either more dramatic or less dramatic? Did they play around with the images to make me think something that wasn't really there? Those kinds of things. We can also mislead with data, not just with a graph. The mean, median, and mode, and we're going to talk more about statistics later on in the class, but the mean is what you would commonly known as average. The median is the number right in the middle. If we list them all from highest to lowest, it's the one in the middle. And the mode is the one that occurs the most. Like I said, we're going to talk about statistics a lot later on in the course. Just for this exercise, I want you to have a rough idea of what those words are. Mean is what you would commonly call the average. Median is in the middle, if we list them highest to lowest. And mode is the one that occurs the most. It's the most common. These are all what are referred to as measures of central tendency. And it's important to note that any one of these can be used when you describe a data set. So, for a fire department in a small town, the mean salary of the employees is $50,000. The median salary is $46,000, and the mode salary is $40,000. What I want you to answer for me is, if there were salary negotiations taking place, which one of those numbers would the employees use in their communications with the public? I'm going to make a poll for this one. So the way that the poll question is phrased is, any of these numbers can be used when describing a data set. And one of the ways we'll use that is we'll say any one of these numbers can be called typical. So any one of these could be described as the typical salary of somebody who works at this fire department. If salary negotiations were going on and you were negotiating and you were talking to a newspaper reporter, which one of those numbers would say is the typical salary? Another, I don't know, 20 seconds on this and then talk about it. All right, let's see what we've got for this one. Oh, how about that? 4, 4, and 3. So we are spread pretty much evenly across the three. Okay, I'm really glad we talked about this because it could be the kind of thing that pops up on a quiz. And my intention was for it to be an obvious answer, but clearly that wasn't the case. All right, what may have happened here is that you all may have some previous knowledge of statistics, which I think is a good thing. That'll really help us later on. You also just may be sort of honest and reasonable people. That's a good thing too. What I want you to think of here is the key to the way that I imagine this question being answered is we're in salary negotiations and we're the employees. And if I'm communicating with the public, I want the public to be on my side. I want the public to think, my goodness, those fire department employees need a raise desperately. So while it's true that the mean and more likely the median are probably the best representations of the salaries of our fire department, if I'm going to try to convince the public that we deserve a raise and I'm allowed to use this number, then that's the number I'm going to use. I'm going to say, when I interview with that reporter, I'm going to say, the most common salary at our fire department is $40,000 a year. It's time for us to get a raise. And so what I was after here with this question was not necessarily just the mode, but as an employee in a salary negotiation situation, I want to use whichever of these numbers gives me the best advantage. And since the mode happened to be the lowest of the numbers in this case, then that's the number that I'm going to go with. If I were the city council, who's going to be also in this negotiation, while the employees come out and say the most common salary is 40,000, then if I'm on the city council, I'm going to say, well, that may be true, but the mean salary, the average salary is 50,000. So if I was the city council here, then I would want to use the mean because that's the biggest number and that would generate in theory, the least amount of sympathy from the public. I hope that makes sense. That was kind of what I was going for with the question. And it could be prior knowledge of statistics may have changed the way you did this because in a lot of cases, we'll see this later on, the mean is the best representation. But if I get to pick which number gets put out there and I have a side, then I want to use the number that gives my side the strongest potential case.